Welcome friends. Today we are going to see advanced memory management in operating systems for this massive open online course. So, here we all know that operating system is the major thing which is handling the user input and giving the result for the ultimate result for the user. So, in order to cater the need for the end user, the user data will be stored in a memory like how we use brain for storing data and how we process the data and we react. The systems also will use the data, store the result in the memory, data in the memory, and it produces the result. So, we all know that the most time consuming process that is happening in a computer system is memory read and memory write. So, if you keep on reading data from the memory and if you keep on writing data from the memory, it consumes a lot of time. So, the current modern day operating systems and applications are not in favor of such kind of time delaying process happening in the system. Today, we are going to cover the topic which is related to how memory is governed, how it can be managed effectively, thereby we can reduce the latency during the process running the system. So, here we are going to cover the topics like the purpose of the need for advanced memory management systems. We use techniques like copy and write, kernel memory allocation, and how the kernel and user memory allocation is compared, and how buddy systems are used for allocating memory, and how memory compression techniques is used in the modern day operating systems. So, here we all know that modern operating systems are in a huge demand of handling data which is generated by sensors, which is generated by human input devices like mic, camera, all the input devices connected in the computer system. So, this data has to be stored in the memory before getting processed by the system. So, when you store the data in the memory, this data has to be retrieved when it is under execution, and sometimes we will store data intermediately in the memory again, and ultimately we get the result. So, if you do that continuously and for quite a long time, so it takes a lot of time, because as I said, memory read and memory write is the most time consuming process in the operating system in the overall execution process. So, we have introduced so many techniques in the modern day operating systems that can avoid too much of writing and too much of reading from the memory. So, it is like a compromise where whenever there is a need to write, we can write, otherwise no need to write in the memory. Keeping that in mind, they have introduced a few techniques. We call it as the memory management techniques like copy and write, kernel memory allocation, and memory compression. So, copy and write is the basic technique which optimizes process creation and sharing, and kernel memory allocation is how efficiently the memory for OS internal operations can be handled. The last is the memory compression, which is widely used in current mobile operating systems, especially where we are having very less resources, constrained devices. So, we can use this kind of memory compression techniques where we compress the data which is not used. Whenever it is necessary, we can decompress and we can use. So, likewise many optimizations are carried out. So, these are the main 3 optimizations in the memory management techniques that you are going to see today. So, here the main purpose of AMM is as I said, the today's application demands large memory footprints like the browsers which we are using today, and the virtual machines that are inbuilt for carrying out tasks, and of course, the latest thing called AI models, where it needs lot of data to be trained, and this training model will give absolute predictions. So, for this kind of operations, we need to handle memory efficiently. So, all these techniques will play a major role for supplying data whenever it is required for execution. So, how the advanced memory management technique helps in executing things faster? So, by avoiding certain things and by invoking certain things, we can achieve this. First one is it avoids excessive swapping of data. So, in OS, as we all know that memory is having a hierarchy, like it starts with flip flops, registers, then main memory, then secondary memory, and we have secondary memory like hard disks, large amount of storage space disks. So, it is like a pyramid where the flip flops are the smallest unit and where we can store data. It stores 1 bit of data, whereas the hard disk or the secondary device, it stores large amount of data. So, if you store large amount of data, then the amount of time required to retrieve the data will be more. So, it is the scenario which we all know basically. So, if you do swapping, when generally swapping will happen, suppose if I am accessing a data from the memory, if the data is not there in the cache memory, so what we will do, we will swap this data to the secondary memory or to the main memory, and again we will take the data which is currently required. So, whenever you are doing this swap, it requires some cycles to do this operation. It takes a lot of time because the data has to be sent, it has to capture the bus, it has to be sent to the bus to the memory unit, and memory unit will again capture the bus, it will send data again to this cache memory. So, this swapping would take a lot of time. So, if you do too much of swapping, then you are wasting too much of time and only do the swapping rather than executing the program, because data is not ready for execution. So, this advanced memory management techniques will avoid too much of swapping process. So, that is the first thing which we have to avoid. The second one is memory fragmentation. We all know that memory is not a single block as a whole. So, we divide that into many pieces, and if these pieces are having indefinite size blocks and these blocks are not appropriate to the size which is required, then lot of spaces will be left unused. So, what we have to do is we have to do split the blocks and we have to do fragmentation process. So, if you do that process, that also will take a lot of time, because we have to move the memory blocks to accommodate the current requirement. So, memory fragmentation is the thing which we can avoid. The third is memory bottlenecks in multitasking. So, if you do multitasking, definitely many tasks may require a particular data, and this data will be stored in the memory, will be available in the memory, and this memory has to be ensured that the data is provided at the right time for maintaining the consistency. So, these are the techniques which you have to avoid. And the next is where it is required. Mainly it is required in cloud computing platforms, where data will be stored in the cloud, and many users can access based on the access priority, access privileges. The next is container orchestrators like Kubernetes and Docker. So, where we have mechanisms to run multiple processes, then high performance servers and smartphones with limited RAM. So, definitely the last one is more critical, because nowadays we are using mobile phones as like modern day computers. So, though the mobile device is doing smart things, but still the memory access time has to be reduced to make the process faster. What they did in smartphones is, with available RAM, they will apply some techniques which can optimize the usage of memory by using memory compression techniques that we will discuss in further slides. So, it ensures both efficiency and stability under heavy loads. So, since the operating system is built in such a way that it can handle any amount of data, and with respect to the load imbalances. So, all these things has to be handled without any issue. That is why we have to manage the memory properly. That is why we call it as advanced memory management. Earlier memory management is like, we have processor, we have cache memory, we have main memory, just we can swap in and swap out and we can carry out the process. But now a small device, a smart device is doing a lot of computation, and this computation can be done efficiently and quickly by using these optimization techniques. We call that as advanced memory management techniques. So, the first option is copy on write. As we discussed, it is a memory optimization technique where multiple processes share the same memory pages. Typically, if you call for system call, it will create a child process. So, when you create a child process, both parent and child will have a process space. So, what we have to do is, whenever there is no write operation is happening, there is no need for having a separate address space for the child. You can use the same space. For example, if I am reading a book, any other person can also read the book at the same time. But if I am writing something in the book, this writing should be done only the user who is going to write has to access the book. Others will be waiting for the book get updated. So, same way, if no writing is happening, still the data can be shared and multiple processes can view. But if any process is trying to update the data, then we have to ensure that another copy has to be made, and only in that copy we have to make a write and we have to update it again. So, this is how copy on write mechanism is implemented. So, memory pages remain shared as long as no processes modify them. So, if nobody is modifying, there is no harm in sharing the page. It is like seeing a board or seeing a advertisement board where the trespassers will just looking at the board. It does not mean that we are going to modify any content, all can see at the same time. When a write occurs, the OS creates a new private copy of the page to preserve each process memory integrity. So, what we have to do, whenever if you want to make a write, any process is attempting to make a write, then we have to make a copy. This copy only we have to update. So, if you are not making any write, there is no need for making a private copy. That is the ultimate job of copy on write mechanism. Reduces overhead by delaying duplication until absolutely required. If there is no requirement, there is no need to duplicate the copy of the memory. That way we can save considerable amount of time and memory as well, in order to save the unwanted mechanisms that is happening in the system. Helps avoid unnecessary copying of entire data segments like stack, heap and code full. So, this is the main basic mechanism which we deploy in almost in all the operating systems. So, how it actually works, as it is like the after fork, both parent and child point to the same physical memory pages using identical page table. No, so far no issues, both are referring to the same thing. OS marks these shared pages as read only by default. So, if you mark this as read only you can read. If somebody wants to write, any of the parent or child, if it wants to write, then we have to make a copy to take modification. If either process attempts to write, what will happen? Since you are making this pages as read only privilege, and if anybody is attempting to write, then it is violating the rule. So, what it happens when you attempt to write a read only page, the CPU will trigger a page fault. So, page fault is what? I need a page, the page is not available. So, it generates a interrupt called page fault. This page fault is generated because the access privilege is only read only. So, kernel allocates a new physical page for the writing process. So, now since it is read only, you cannot write. So, it is creating a new page, and this new page you can write. Modified data is written only to the new page, not to the original version. So, it ensures the isolation between the original and the updated one. This mechanism avoids copying until a write operation is initiated, minimizing the memory consumption. That is the way how COW works, copy and write. So, what is the main advantage of doing this? It looks simple, but it happens millions of times, because multiple processes will be running parallelly, and all these processes will create so many child process in the overall system execution. So, if the child process is not modifying data, there is no point in making a new copy. So, it benefits in increasing the performance of the overall system during process creation, because large memory blocks are not copied instantaneously when the process is created. It reduces RAM consumption, especially when the processes share large immutable data. That is the main thing which we have to consider. The list is efficient memory sharing for static data, shared libraries and common code segments. So, all these common code segment, private data, all are having its own criteria for helping the process to get to be executed. So, this copy and write mechanism is very much helpful when there is no modification is happening over the data, just data is shared for reading purpose. Helps scale systems the large number of concurrent processes. This will be having more impact in a concurrent systems where many processes are running simultaneously, and all these processes are sharing a common data. So, if the common data is shared and nobody is modifying the data, and COW is having a huge impact in the performance. So, generally where we use COW? So, we use COW in creating child process using fork in Unix and Linux systems. Yes, of course, we all studying about virtualization computers. So, we have the kernel based virtualization systems, and quick emulators uses this kind of copy and write store images. So, all these will have a huge impact when something is not happening, when it is not required. Memory deduplication across virtual machines, it is also using COW, copy and write. It plays a major role in virtualization process of operating system. Again, it plays a major role in containers where you use Docker. It uses copy and write file systems. Best example is overlay FS and AVFS. It is advanced multi-layered unification file system where the lower layer prevents writing, whereas we can have an overlay upper layer which can enable writing. So, this kind of packages we can have to use copy and write as a better alternative. Then we can use this for share libraries. Process can share common library count pages until write access that we already discussed. So, if you look at the diagrams, you can understand that the first one is two virtual machines VM1 and VM2 are accessing the pages, page ABC, and these pages are available in the physical memory. So, they can access the page till it is updating the page. For example, if a particular virtual machine VM2 is trying to update, then we can create a page separately, page A separately, and we can write on this page. Similarly, here we can use this in case of overlay file system where we have the base layer, file 1 and file 2, and if you want to have an updation with the access privileges, we can have another layer. Likewise, we can have overlay file system which enables to achieve a better performance, especially in containerizations. Last one is shared libraries where we can have a shared one. Here this represents a file system where the actual data is BND, and if you want to modify, this BND will be duplicated, and this duplicate copy will be residing aside. So, BND is the original data, this BND is the data which is updated. So, the second form of memory management is kernel memory allocation. So, it is very important to allocate kernel memory with higher optimization techniques, because it stores the most critical OS components like process tables, interrupt vectors, device buffers. These are all the things which are unique for the processes, and this has to be stored and handled efficiently. So, it needs specialized allocation mechanisms because kernel operations require deterministic low latency access. So, in the kernel mechanism, you have to be aware that how much time it will take for doing this particular job, thereby the next job will be assigned the CPU. So, we are much bothered about how kernel operations are carried out. The second is some hardware requires physically contiguous memory regions. Direct memory access DMA is one thing which helps in executing things faster. So, in that case we need to provide continuous memory regions which can help to assign the data which is required during the process execution. Kernel memory cannot be swapped out, must be used efficiently. We cannot do kernel memory swapping in, swapping out because it will have a huge influence in the performance of the system. So, better to avoid swapping in, swapping out in kernel memory access. Use advanced allocators to minimize fragmentation and maximize speed. So, we have a separate allocation mechanisms we will discuss in the further slides that plays a huge role in kernel memory allocation. So, if you look at the kernel space and the user space, users also have the privilege of creating memory space by using malloc functions like yes, in C we use malloc function for getting a dynamic memory. Similarly, in the kernel also we will create or allocate memory blocks using techniques like buddy systems, slabs, and so on. We will discuss each in detail. In user space, memory is swappable. If you swap user's memory, it is not going to affect the system overall, it is going to affect to some extent only to the user. But if you, in case if you swap a kernel memory space, it is very time consuming, it affects the system's overall performance. So, you cannot swap kernel memory space. Fragmentation less critical in user space because it affects only the individual user, it is not going to affect the system overall, whereas here fragmentation will play a huge impact, it is like an avalanche effect. So, if you do a small fragmentation, it will have a huge effect in the overall execution time of the process. So, it should be strictly controlled by using appropriate management techniques. So, the performance requirement is not that critical in user space, whereas in kernel space, as we all know that interrupts are categorized as software interrupt, hardware interrupt like that. So, hardware interrupts are to be given higher priority. So, the kernel is a system level interrupt generated. So, it has to be given higher priority with quick attention. So, system calls as well. So, these are all things which has to be handled efficiently and quickly. So, how to do this? We have techniques like buddy system, slab allocator, and the slab there is an advanced variation of slab allocation, we call it a slab or slob. So, we go with the buddy system. So, what buddy system will do is it splits memory into blocks of size 2 power n. So, it keeps on dividing the memory. For example, if you look at this diagram, you can see the 128 block size is divided into 2 halves of 64 each, and again each 64 is again divided into 32 and 32, and again this 32 will be divided into 16 like that. So, what is the purpose of doing this kind of small buddies? We call it as, these are all called buddies. The main reason for dividing that into equal halves is, suppose if there is any requirement, you can choose the respective buddy which is most appropriate for holding the data. If you allocate, for example, if the requirement is very small and if you allocate a larger memory block, then most of the memory space will be wasted. So, if you have different values of buddies, you can choose the appropriate buddy and it will lead to only minimal wastage of memory. So, that is the buddy system, which is a straightforward and simple system which is generally followed in operating system. So, that is why it is the memory is divided into blocks of size 2 power n. It is quick merging and splitting. So, we can easily split the memory 128 now, you can divide that into 64 and 64, and if you want to merge 64 and 64 can be merged to form 128. So, this is very easy to merge and split, good for large or contiguous allocations. So, if you want to go for a higher block allocation, still this will work fine. The second option is a slab allocator, we will discuss in detail also. The design for frequently used kernel objects. So, we have to, we know that how frequent we are going to access the object. So, based on the frequency of accessing, this have a different structure of allocating the objects. Next word is slab, which is slightly a better version of slab allocation. So, here we use minimal fragmentation and high concurrency mechanism, which gives a better performance than slab allocation. And slab is mainly designed for deploying in constrained devices like embedded devices, which is extremely lightweight. So, it is like a simple linked list connection of blocks. So, if it can connect various blocks and it can operate. So, there is no complex mechanism involved for implementing this technique. So, what is buddy system? As we said, buddy system maintains free memory in groups called buddies that can be merged. So, allocation steps is locate smallest block which is greater than the required size. So, we have to find the appropriate block which is just greater than the required size, split until best fit is achieved. Suppose if I need 10 KB for example, I have 40 kb, then what I have to do? I have to divide this 40 into 2 halves, that is 20 and 20. I need only 10. So, this 20 again can be divided into 10 10. So, likewise we can divide the buddies into smaller buddies as per the need. So, we can assign the memory block after the proper buddy is created. So, in this example we have 32, but the requirement is 18, they have considered 18. So, 18 if you split 32 into again 2 halves, it becomes 16 and 16, which is not appropriate for the requirement. So, no need to split further. So, you can use the 32 block, 32 size for this 18 kb. Of course, we are losing some 14 kb. That is the minimal wastage we can do in this case. So, if the adjacent buddy block is also free, merge into a larger block. So, if a particular buddy is free, you can merge into a larger block, thereby if any requirement comes for that size, you can use that. So, the main advantage is the splitting and merging is faster. So, overall the operation is much faster. It is very simple to manage, either you have to split into 2 halves or you have to merge the 2 halves. Easy coalescing reduces external fragmentation, that is the main thing. If you do fragmentation quite often, it increases the time. So, it avoids its external fragmentation by just merging the respective buddies together. So, disadvantage is internal fragmentation due to power of 2 block sizes. So, here that is the problem. Internal fragmentation is, for example, if you need 18 kb, but you have 32, so 14 kbs are wasted. That is the internal fragmentation issue. That is the one disadvantage we can say with the buddy systems. The second type is slab allocator. It is optimized for objects that are frequently created or destroyed. So, you have to keep track of objects which are accessed frequently and which are closed frequently. So, based on this statistical data, we can go for slab allocation method. This organizes memory into cache for each object type and slabs for group of objects, and objects one final allocation unit as object. So, if you look at this diagram, we can have different objects of different sizes. For example, 3 kb objects and 7 kb objects. In the caches, we have different cache for each. For example, 3 kb objects, we have cache blocks. It is about per CPU type. So, here we have a different cache, and for 7 kb objects we have a different cache. If you go for slab allocation, the entire slab allocation will be used for each type of objects. So, only thing is we have to use the contiguous pages which are required for the size of the objects which we are going to map. So, the benefits is no need for reinitialization structures, reduce overhead, because already slabs are formed based on the contiguous memory. So, here we have one slab, here we have another slab. So, these slabs are for this 7 kb objects and this slab is for this 3 kb objects. Almost zero fragmentation, we are going for fragmentation less type of allocation procedure used for file descriptors, various objects which have variable sizes. That is the main thing. The next and most important thing which we currently adopt in mobile constrained devices is the memory compression technique. So, here we have the OS compresses less used pages instead of writing them to disk. So, less used pages, if you write them to the disk, it will take a lot of time. So, you compress all those unused pages and put that in the memory. So, it will occupy only lesser portion. So, whenever there is a need, you can decompress and you can use. This is developed for the sake of meeting out the constrained resource in the systems like mobile devices. It reduces swap space and dramatically improves system responsiveness. Yes, if the swap space is reduced, response time also will be reduced and it will give quicker responses. Functions as an in-memory alternative to swapping. So, here instead of doing swapping, we are doing an alternative mechanism within the memory by allocating a portion which is storing a compressed form of the data. Acts as a virtual expansion of RAM without physical upgrade. So, if you see, if I have a 10 MB RAM, if you apply compression technique over the 10 MB RAM, actually effectively you are storing more than 10 MB, but actual physical space is only 10 MB. It means what, we are compressing the data and storing into a particular portion. If you decompress it, it will be exceeding the 10 MB of memory. So, that is the main thing which is used in the, especially in mobile devices, as particularly beneficial for mobile or low memory devices. So, memory pages evaluated based on recency and frequency of access. Only thing is we have to maintain how frequent you are accessing the particular memory page. So, based on that only this compression technique will be effectively implemented. So, unused pages will be compressed and put that in the side. So, we use various fast algorithms like LZO and Z standard, LZ4 type of fast compression algorithms. So, these algorithms have a criteria like how fast it is compressing and decompressing and how much it is compressing. This is the major criteria. Based on these criteria only we have to decide which one we have. These are all much faster algorithms. Compressed pages stored in a special in-memory pool called, we call it as a portion of memory in the mobile memory systems called ZRAM or a compressed cache. So, that portion only will contain the unused pages. when process requests the data, page is decompressed and returned to active memory. So, it will be decompressed and it will be returned to active memory for its processing. Till then it will be like a dormant. Linux uses both the JetSwap and JetRAM techniques. Okay. So, based on the operating systems we use for mobile, we use this kind of compression techniques. So, the benefits of using this compression technique is reduces disk I/O operations. So, there is no need for I/O based operations because reading and writing takes a lot of time. Huge performance boost. So, since we are not going out of the memory unnecessarily, the performance will be increased. Improves responsiveness when many apps are running concurrently. Yeah, if you the impact of this compression technique will be visibly seen when many applications are running simultaneously. There we can see the performance. Allows more apps to remain in memory, preventing premature eviction. So, most of them will be in the memory itself without coming out or completing its job. Reduces wear and tear on SSDs due to fewer swap writes. If you keep on writing reading from the disk, then wear and tear will happen in the disk. So, it is a solid state drive. So, in order to avoid such frequent writing, this technique helps in storing that in the memory itself. So, this is how diagram shows that before memory compression it looks like a larger scale storage, and after that it becomes small. So, the inactive portion is compressed and stored in a lesser space, and the active portion is retained as it is, and the free space is left free. So, before memory compression it occupies fully as per this diagram, but after memory compression we compress the inactive portion and we have left out with some free space. That is the advantage. So, what is drawback of this compression? So, the compression and decompression, it runs an algorithm as we discussed LZ for all this. These algorithms will need CPU cycles for its computation. So, that is one drawback. Under heavy CPU load may cause minor slowdowns. So, if this load is heavy and this compression algorithm runs, there is a performance degradation. Some data types are not compressible. So, there are issues in the format compatibility. Certain things may not be compressed effectively because of the file formatting issues. Excessive compression can lead to thrashing if system constantly compresses and decompresses. So, if you do not have a proper statistics about how frequent you access the page, this will lead to frequent compression, frequent decompression, and if you do that, the compression decompression is not going to take part in the performance. Okay. So, it takes time. So, frequently if you do that, it will end up with a lower performance, which we call generally in operating system as thrashing. Too much of swapping is called thrashing generally. Here too much of compression and decompression is called thrashing. So, not a full substitute for adequate physical RAM. It is not exactly substituting the physical RAM, but it is an optimization technique which uses compression technique for that. So, these are the examples of compression implementation, JetRAM in Linux, JetSwap, KSM, kernel same space merging. Then in Windows 10 we have similar versions, and Mac OS also having compression techniques. At last we are concluding the session with the summary, like we discussed about the various techniques of copy on write, kernel allocators and memory compression techniques, which all these three will play a major role in reducing the execution time and increasing the performance of the system. So, it is very much essential to meet out the modern computing demands. All these three techniques will help in faster execution and efficient utilization of memory and reduce system overhead and improve overall user experience. So, this is widely used in all the modern operating systems. Okay, thank you. So, we will see the subsequent topics in the next sessions. Thank you.